Your test 4 review. Problem number 1, the sine of theta equals 4/5, and theta is greater than 0, less than pi over 2. And we want to find the cosine of 2 theta. Alright, theta is between 0 and pi over 2. That just tells us that we're in the first quadrant, which for this problem we don't even need. We have 3 different formulas for the cosine of 2 theta. Right here on a formula sheet, I have these listed. I would use the one, we were given the sine of theta, so I would use the formula that just has sine in it. So that would be the third formula, 1 minus 2 sine squared theta. So 1 minus 2 sine squared theta. We were given that sine of theta is 4/5, so this is going to be 1 minus 2 times 4/5 squared. It's sine squared, so 4/5 squared. So that's 1 minus 2 times 16/25, or 1 minus what? 32/25. Get a common denominator of 25, so it's going to be 25 minus 32 over 25, or negative 7 over 25, and that is A. Alright. Number 2, we're given that the sine of theta is 1/4, and we're also told that tangent is greater than 0. That means tangent is positive. So, and we want to find the cosine of theta over 2. Cosine of theta over 2. Alright, so we need to figure out which quadrant we're in. If sine is positive 1/2 and tangent is positive, it's greater than 0, there's only one quadrant where sine and tangent are both positive, and that's the first quadrant. So we're in the first quadrant again. Alright, my formula for a half angle formula for cosine is plus or minus the square root of 1 plus cosine theta all over 2. So since we're in the first quadrant, it's going to be positive, and then I need to figure out what the cosine of theta is. If I know I'm in the first quadrant and the sine of theta is 1/4, remember sine is y over r, so I can solve for x because cosine is x over r. So if I solve for x, I'll be able to figure out what cosine theta is equal to. To solve for x, you use the formula x squared plus y squared equals r squared. So x squared plus 1 squared equals 4 squared. So x squared plus 1 equals 16. X squared equals 15. Take square root of both sides. X equals plus or minus the square root of 15. Since we're in the first quadrant, it's going to be positive. So x is a positive square root of 15. Alright, so now let's follow our formula. It's going to be plus, because we're in the first quadrant, and then square root of 1 plus, we need the cosine of theta. So cosine of theta is the square root of 15 over 4. We figured out x is the square root of 15 and r is 4. Alright, and that's all over 2. Now we want to figure out what number can I multiply times the numerator and denominator so that I get rid of this denominator and I can take the square root of this denominator. So usually I would say let's just start with 2, but 2 is not going to get rid of this denominator. You say, well, what about 4? 4 would get rid of the denominator, but it also makes this denominator 8, and you can't take the square root of 8. Alright, so let's try multiples of 4. The next multiple is 8. 8 would get rid of this denominator, and it would make this denominator 16, and I can take the square root of 16. So let's use 8. Multiply the numerator and denominator by 8. So that's going to make this 8 plus when you multiply this times 8, you say 8 divided by 4 is 2 squares of 15. That's all over 16. And now we want to take the square root of this denominator. So my final answer is the square root of 8 plus 2 squares of 15 all over 4. And that gives me my answer. So that is B on your practice test. B is in beta. Number 3, we're given the tangent of theta equals 8 over 15, and theta is greater than pi, less than 3 pi over 2. Find the sine of 2 theta. So we only have one formula for the sine of 2 theta, and that is 2 sine theta times cosine theta. Now we were told, we were given tangent, and we were told that theta is greater than pi, less than 3 pi over 2. Here's pi, here's 3 pi over 2, so theta is in this quadrant here. Since theta is in this quadrant, keep in mind that if we solve for, or if we have x or y, the x has to be negative and the y has to be negative. Well, we were given tangent of theta, and tangent of theta is y over x. But if you just read this as it is without knowing what quadrant it's in, you'd say y was a positive 8 and x was a positive 15. But since we're in the third quadrant, that means y is a negative 8 and x is a negative 15. Alright, we need that because we need to know what sine of theta and cosine of theta are both equal to. Sine of theta is y over r. Cosine of theta is x over r. So we don't have r. So we need to solve for r. So do that by using x squared plus y squared equals r squared. So negative 8 squared plus negative 15 squared equals r squared. Or 64 plus 225 equals r squared. So that's going to be 289 equals r squared. So r equals the square root of 289, which is equal to, does that simplify? Let's check it out and see. So 289 square root 17. Alright, so now we can find sine and cosine. So sine is negative 8 over 17. Cosine is negative 15 over 17. Okay, so now that we have solved for sine and cosine, we can plug those in up here. So it's 2 times negative 8 seventeenths times negative 15 seventeenths. So a negative times a negative is a positive. And then, let's see, 2 times 8 times 15 is 240. And 17 times 17 is 289. Alright, so our answer is 240 over 289, which is A. Number 4, cosine of theta equals 20 over 29. Theta is greater than 3 pi over 2 and less than 2 pi. So that tells us that we're in the fourth quadrant. Remember, in the fourth quadrant, x's are positive and y's are negative. Alright, we want to find sine of 2 theta on this problem. Again, we only have one formula. That's 2 times sine of theta times cosine of theta. We were given cosine of theta. We need to find sine of theta. Alright, remember sine is y over r, cosine is x over r. And since we're in the fourth quadrant, when we solve for y, we need to make it negative. So use x squared plus y squared equals r squared. So 20 squared plus y squared equals 29 squared. So 400 plus y squared equals 841. Subtract 400 from both sides, and we're going to get y squared equals 441. So if I take the square root of both sides, you get y equals plus or minus the square root of 441, but since we're in the fourth quadrant, we need to take the negative answer. So y equals negative square root of 441. So now, sine is y over r, so it's going to be negative square root of 441 over 29. So that's what we plug in here for sine. Negative square root of 441 over 29. Cosine is 20 over 29. Can we take the square root of 441? Let's see. 441 square root 21. So that's actually, in disguise, it's 21. Alright, so we have just one negative, so our answer is going to be negative. 2 times 21 times 20. So it's going to be negative 840 over 29 times 29 is 841. So negative 840 over 841. The answer for number 4 is C. Alright, number 5. Sine of theta is equal to 1/4. Theta is less than 0, greater than 0, but less than pi over 2. So that tells me that my angle is in the first quadrant. Alright, we want to find the sine of theta over 2. My formula is plus or minus the square root of 1 minus cosine of theta over 2. So that means I'm going to need to find the cosine of theta. I was given the sine of theta. Cosine is x over r. We know sine is y over r, right? So y is 1, r is 4. Let's solve for x. So x squared plus y squared equals r squared. Or x squared plus 1 equals 16. X squared equals 15. Take the square root of both sides. So x equals plus or minus the square root of 15. We're in the first quadrant, so it's going to be positive. Alright, we're looking for cosine for our formula. So it's going to be square root of 15 over, my r was 4. Alright, I'm in the first quadrant, so the plus or minus on the outside, this is positive. Square root of 1 minus the cosine of theta is equal to the square root of 15 over 4. That's all over 2. This is just like the previous problem. We simplify. Multiplying by a 2 doesn't work. Multiplying by a 4 doesn't work because that would make the denominator something I couldn't take the square root of. But multiplying by an 8 will work. So just like one of the previous problems on this test, I'll have the square root of 8. I think the only difference is I had a plus here instead of a minus. It's going to be the square root of 8 minus 2 square roots of 15. And then the bottom is the square root of 16, so it's all over 4. So that's C on number 5. Answer C. Alright, number 6. Cosine of theta is equal to 1/4. And cosecant is greater than 0. So that tells us that cosine is a positive 1/4, cosecant is positive. If cosecant is positive, sine is also positive. There's only one quadrant where cosine and sine are both positive, and that's the first quadrant. So theta is in the first quadrant. I want to find, again, the sine of theta over 2. So I use the same formula that I used on the previous problem. The only difference in this problem is I'm given cosine of theta at the beginning, so I don't have to solve for it. Okay, so I can go right to the problem, right to the formula. It's going to be plus, since we're in the first quadrant. I usually don't write that in front, but the square root of 1 minus, we were given that cosine of theta is 1/4. So 1 minus 1/4 all over 2. So that's going to be the square root of 1 minus 1/4 is 3/4. So that's 3/4 over 2. So take that, flip and multiply, and let's see what we have. It's going to be equal to the square root of 3/8, which is the square root of 3 over the square root of 8. And then the square root of 8 can be rewritten. The square root of 8 is 2 square roots of 2. Now to rationalize the denominator, I multiply the top and bottom by the square root of 2. So the numerator becomes the square root of 6. The denominator is going to be 2 times 2, so 4. The answer is the square root of 6 over 4. That's A. Alright, number 7. Tangent of theta equals 3. Theta is greater than pi, less than 3 pi over 2. Let's find the tangent of theta over 2. Alright, so we are told that theta is in the third quadrant. Now this one's going to be a little tricky. All the other ones we've worked with half angle have been in the first quadrant, so we haven't had to worry about moving it, because if theta was in the first quadrant, theta divided by 2 is also in the first quadrant. This one here, though, theta is in the third quadrant, so that is why we have a positive 3 here. So we're going to have to use that to find sine and cosine because of our formula. But we need to be careful with the plus or minus sign for this. Okay? The plus or minus sign comes from where theta over 2 is located. So to figure out where theta over 2 is located, you would have to divide all of these by 2. So theta over 2 is greater than pi over 2 and less than, that'll be 3 pi over 4 when you flip and multiply. So theta over 2 is actually, here's pi over 2, and 3 pi over 4 would be in here. So theta over 2 is actually in the second quadrant. So we need to make sure we use a minus with our answer. And then we got to know the formula. Well, this formula is a little strange, so I'm going to pull up my formula sheet again. We can get these are the half angle formulas. We can get the formula we use by taking the square root of both sides. We just have to be careful on the formula sheet. This is theta and this is 2 theta. So we want that to be theta over 2, and those are both going to be theta. So 1 minus cosine over 1 plus cosine, and we have to do the square root. So square root 1 minus cosine over 1 plus cosine. Let me double check, make sure I got that right. Yeah. Alright, so we actually don't have to solve for sine, but we do have to solve for cosine on this one. Alright, so there's tangent of theta equals 3. If tangent of theta is equal to 3, remember tangent is y over x. So you can think about that like 3 over 1. So y is 3 and x is 1. We just need to figure out what r is so that we can solve for cosine. So that's 1 squared plus 3 squared equals r squared. So that's 1 plus 9 or 10 equals r squared. So r is going to be the square root of 10. Alright, so my answer is going to be negative square root of 1 minus, well, what is cosine? If r is the square root of 10, cosine is x over r, so cosine is 1 over the square root of 10, which if you rationalize is square root of 10 over 10. Alright, so we're going to have some work to do over here when we plug these in. So we have 1 minus square root of 10 over 10 over 1 plus square root of 10 over 10. So the first thing that I would do to simplify this is I would get rid of the denominator of 10. So I would multiply the numerator and denominator by 10. Alright, so it's negative square root of, this is going to be 10 minus the square root of 10 over 10 plus the square root of 10. Now, to rationalize this denominator, I need to multiply by the conjugate. So the conjugate would be 10 minus the square root of 10. So that's what I multiply times the numerator and denominator. Alright, when you multiply out the numerator, you FOIL. So that's going to be 100 minus 10 square roots of 10 minus 10 square roots of 10. So that's minus 20 square roots of 10. And then negative square root of 10 times negative square root of 10 is going to be a positive 10. Alright, that's all over. Now multiply out the denominators. You can FOIL, or remember when you multiply conjugates, you just multiply the first terms. So that's 100 minus multiply the last terms. So that's going to be minus 10. Alright, so in my numerator, I'm going to have 110 minus 20 square roots of 10 over 90. From this point, do you see that you can simplify because of, you can take this, this, and this and divide by the same number. What can we divide in all of those? 10, right? So that would make this negative square root of 11 minus 2 square roots of 10 over 9. We don't have a fraction in the numerator, and we can take the square root of the denominator. So that's negative square root of 11 minus 2 square roots of 10, that's your numerator, all over 3. Alright, so let's take a look at the tangent of 255 degrees. Find the exact value. So there's a couple ways we could do this. We are going to use the sum and difference formulas. So I actually need to figure out a difference to give me 255 degrees from the common angle measures. So, here are the common angle measures. Looks like, let's see, 255 would be 225 plus 30. So that's what I would use, 225 degrees plus 30 degrees. And then we want to use the sum formula for tangent. Tangent alpha plus or minus tangent beta over 1 minus or plus tangent alpha times tangent beta. Alright, so this is the tangent of 225 degrees plus 30 degrees. And the formula is tangent alpha, so tangent 225 degrees. And then when this is plus, up here, you have to be careful with the formula sheet, or the formula. When this is plus up here, this is minus down here. Alright, so it's going to be plus tangent of 30 degrees over 1 minus tangent of 225 degrees times the tangent of 30 degrees. Alright, so the tangent of 225 degrees, you can get really quick from your formula sheet. Remember, it's y divided by x. 225 is right here. Y divided by x, it's negative square root of 2 over 2 divided by negative square root of 2 over 2. So that's going to be 1 plus the tangent of 30 degrees. Again, here's 30 degrees on the unit circle. It's y over x. So 1/2 divided by square root of 3 over 2. That would be 1 over the square root of 3, or square root of 3 over 3. Okay? And that's over 1 minus tangent of 225 is 1 times tangent of 30, square root of 3 over 3. Now, let's simplify this, get rid of the fraction, so multiply the numerator and denominator by 3, and you get 3 plus the square root of 3 over 3 minus the square root of 3, and now multiply by the conjugate to rationalize. So that's going to be 9 plus 3 square roots of 3 plus 3 square roots of 3 plus 3 all over 9 minus 3. So that's 12 plus 6 square roots of 3 all over 6. And the way this reduces, you can divide this, this, and this by 6. So that's going to be 2 plus the square root of 3, which is C, the square root of 3 plus 2. Same answer. Number 9, the sine of 15 degrees. Again, there's a couple ways that we could get this answer. We could use half angle, or we could use sum and difference formulas. But I'm going to use the sum or difference formulas. I'm actually going to take the difference. The sine of 45 degrees minus 30 degrees. That's 45 minus 30 is 15. And so just need to make sure that we use the correct formula. So the difference formula for sine, right here, when you subtract, you have sine alpha cosine beta, and we have plus or minus here, so we want to subtract cosine alpha sine beta. Alright, so sine 45 degrees times cosine 30 degrees minus cosine 45 degrees times sine 30 degrees. So it's going to be square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. So that's going to be square root of 6 over 4 minus square root of 2 over 4. Factor out square root of 2. Well, you have a common denominator, so it's going to be square root of 6 minus square root of 2 over 4. That's correct to me, but that choice is down there. The way they get their answer, they factor out a square root of 2. That would leave you with square root of 3 minus 1 all over 4. Alright, and that is D. D is in delta. They actually, oh, that's the answer they actually have. If you get right here, though, what you could do is take all their answers and just multiply that square root of 2 back in, and you'll get this answer. So that would be the way I'd probably leave my answer if I was working on it. But since it's multiple choice, we just kind of have to adapt. All right, number 10, the cosine of 5 pi over 12. A lot of students, especially for these problems, would rather work with degrees because you're doing so much adding or subtracting of angle measures. So I'm fine with that. And so on this one, you can think about this like it's 5 times 180 divided by 12. So it's 75. So that's the same thing as the cosine of 75 degrees. So there's a couple ways we could get 75. You might want to just do one of the simpler ways. That would be the cosine of, you could say 45 degrees plus 30 degrees. Alright, and then we need to use the sum for cosine formula. So it's the cosine of alpha plus beta. When we have a plus here, we put a minus in our formula. So it's cosine alpha cosine beta, and it's going to be minus sine alpha sine beta. So cosine 45 degrees times cosine 30 degrees minus sine 45 degrees times sine 30 degrees. Alright, so that's the square root of 2 over 2 times the square root of 3 over 2 minus square root of 2 over 2 times 1/2. If you look at our work up here for the previous problem, we're getting the exact same numbers. So the answer is going to be exactly the same as the previous problem. Square root of 6 over 4 minus square root of 2 over 4. Square root of 6 minus square root of 2 over 4. Or you could factor that square root of 2 out, and it'd be square root of 2 times square root of 3 minus 1 all over 4. Alright. Now the next 10 problems are the sum or difference to a product, or product to a sum or difference. So just need to make sure that we use the correct formula, and it's pretty much just plugging numbers in. So we have all these formulas here that we can use. So number 11, cosine of 6 theta minus cosine of 2 theta. So this is a difference or a sum. It's a difference, but we want to take that and we want to change it over to a product. So look for the formula that is cosine minus cosine. Okay, and that's going to be -2 sine of alpha plus beta over 2. So 6 theta plus 2 theta, that's 8 theta over 2, which I'll come back and simplify in a second. And then times the sine of alpha minus beta over 2. So that's going to be 6 theta minus 2 theta. That's 4 theta over 2. So that's -2 sine of 4 theta times sine of 2 theta. Alright, and on number 11, that is the answer for A. So that's A. Number 12, sine of 7 theta plus the sine of 3 theta. So make sure you use the right formula. That's going to be 2 times the sine of alpha plus beta over 2. So 7 theta plus 3 theta is 10 theta. 10 theta divided by 2 is 5 theta. Times cosine of alpha minus beta over 2. So 7 theta minus 3 theta is 4 theta. 4 theta divided by 2 is 2 theta. So number 12, that is C. Number 13, the sine of 9 theta times the cosine of 5 theta. So we want to take this product and change it to a sum. So look for the formula that is sine alpha times cosine beta. That's going to be 1/2 times sine of alpha plus beta, so 9 theta plus 5 theta, plus sine of alpha minus beta, so 9 theta minus 5 theta. So it's going to be 1/2 times the sine of 14 theta plus the sine of 4 theta. And that's how we would want to leave our answer. So for number 13, that's D. D is in delta. All right, number 14, sine of 6 theta times the sine of 2 theta. This is a product. We want to change it to a sum. So use the sine times sine, sine alpha sine beta formula. So it's 1/2 times cosine of alpha minus beta. So it's 6 theta minus 2 theta is 4 theta. Minus cosine of alpha plus beta. Alpha plus beta is 6 theta minus 6 theta plus 2 theta, that's 8 theta. So number 14 is D. Number 15, sine of 7 theta times sine of 5 theta. So we're going to use the same formula for that one. It's going to be 1/2 times the cosine of alpha minus beta, so that's the cosine of 2 theta, minus the cosine of alpha plus beta, that's going to be cosine of 12 theta. So number 15 is A. Number 16, sine of 3 theta minus sine of 5 theta. So we want to take this difference and change it into a product. So make sure you use the formula that's sine minus sine, or sine alpha minus sine beta. Alright, we're going to have 2 times the sine of alpha minus beta, so 3 theta minus 5 theta, that's going to be negative 2 theta over 2, times the cosine of alpha plus beta, so that's 8 theta over 2. Alright, so it's going to be 2 sine of negative theta cosine of 4 theta. When you have a negative here, apply the even odd property, so that's going to be negative 2 sine theta cosine 4 theta. Just take the negative and move it in the front. Alright, number 17, we have fractions here, so be careful with the fractions. That's the cosine of 9 theta over 2 plus the cosine of 7 theta over 2. We want to change that sum into a product, so make sure you use the right formula. That's going to be 2 cosine of alpha plus beta. So 9 halves plus 7 halves is 16 halves, and 16 halves is equal to 8. So that's 8 theta divided by 2, though don't forget that. 8 theta divided by 2. That's in the formula, that 2 down there is. Alright, times cosine of alpha minus beta divided by 2. So alpha minus beta, that's going to be 2 theta over 2, which is just theta. Alright, so my answer is 2 cosine 4 theta cosine theta over 2. And number 17, that is C. Problem number 18, the sine of 6 theta minus the sine of 4 theta. Alright, so we want to take this difference and we want to change it into a product. Alright, so that's going to be equal to 2 times the sine of alpha minus beta, so that's 6 theta minus 4 theta divided by 2. So 6 theta minus 4 theta is 2 theta divided by 2. It's just going to be theta, times the cosine of alpha plus beta divided by 2. So 6 theta plus 4 theta is 10 theta divided by 2 is 5 theta. So the answer for number 18 is D. Number 19, the sine of 4 theta minus the sine of 2 theta. Again, it's the difference for sine, so use the same formula. It's going to be 2 times the sine of alpha minus beta divided by 2. So 4 theta minus 2 theta is 2 theta. 2 theta divided by 2 is theta. And the cosine of alpha plus beta divided by 2. So 4 theta plus 2 theta is 6 theta. 6 theta divided by 2 is 3 theta. So the answer for number 19 is A. Last problem, number 20. We're going to take the sine of 7 theta times the cosine of 3 theta and change that over to a sum or difference. And make sure you use the right formula of the product, sine alpha times cosine beta. So that's going to be equal to 1/2 times the sine of alpha plus beta. So it's going to be 10 theta plus the sine of alpha minus beta. That's going to be 4 theta. And that answer is B. And that concludes your test review. Good luck. Problem number 21 says, let's see, we're given this right triangle, and we want to find the cosine of theta for this right triangle. Alright, so recall that cosine is adjacent over hypotenuse. Okay, so if I have this triangle and this is angle theta, then I need the adjacent side, which is the side that touches theta but is not the slanted side, over the hypotenuse, and the hypotenuse is the slanted side. Okay, we don't know what the slanted side is, so I'm going to have to use the Pythagorean Theorem to figure out what the hypotenuse is. So the Pythagorean Theorem says that the sum of the squares of the two legs of a triangle are equal to the square of the hypotenuse of a triangle. So 10 squared plus 7 squared is equal to the hypotenuse, and I'll just make the variable x. So it's equal to x squared. So that's 100 plus 49 equals x squared, or 149 equals x squared. Take the square root of both sides. So x is equal to the square root of 149. Since this is a length, we don't have a plus or minus in front. It's just positive square root of 149. Alright, so cosine is adjacent over hypotenuse. So that's 7 over the square root of 149. And I wouldn't leave my answer like that because you have a radical in the denominator. Okay, so say the square root of 149 times the numerator and denominator. You'll have 7 square roots of 149 over 149. Alright, and that is your answer. Number 22 says solve the right triangle. So we want to solve for all of the sides or angles that we don't have. So we're given this side here is 2, this is 35 degrees, and then since this is a right triangle, we know that this is 90 degrees. So I can figure out this angle. Since I know 2 of the angles of the triangle, angle B is going to be equal to 180 degrees minus 35 degrees minus 90 degrees. Okay? So that's going to be, you can say 90 minus 35, you should get 55 degrees. Alright, so now let's use the given angle and the given side to solve for side A and side C. We could use angle B, but just in case we messed up finding angle B, it's better just to use the things that are given in the problem. So this is the angle measure that we're going to use. So we can consider this to be our theta up here. Okay, so all I want, since I know this angle measure, I want to use this adjacent side, and then from this angle, this is the opposite side. So I want to use a trig function that has adjacent and opposite. And if you recall, tangent of theta is equal to the opposite side over the adjacent side. Okay, so if I set this up using tangent, that's the tangent of 35 degrees is equal to the opposite side is A over the adjacent side, 2. Now when you set up these formulas like this, make sure that you only have one variable. You have to know pretty much everything that you put in your formula except for one value, one variable. Alright, so now we want to solve for A. So to get A by itself here, I'd multiply both sides of the equation by 2. And so A equals 2 times tangent of 35 degrees. Okay, so 2 times, I'm in degree mode, 35 tangent equals. So if I was to round this to say 2 decimal places, side A is approximately 1.40 units. Alright, now I'm going to solve for side C. And you may be thinking, well, since I know these two sides of the triangle, I could use the Pythagorean Theorem. And you could and get close to the answer. You may even get the answer. But since we rounded something, I wouldn't suggest plugging in a rounded value to get some other answer. So what we're going to do is just use the values that were given. We're going to use 35 degrees. And from here, we have the adjacent side. We want to know the hypotenuse. So we need the function that has adjacent and hypotenuse. And that's cosine. Remember, the cosine of theta is equal to the adjacent side over the hypotenuse. So the cosine of 35 degrees is equal to 2, the adjacent side, over c, the hypotenuse. Now to solve for this variable down here, I'm going to have to move some things around. So first you want to multiply both sides of the equation by c. Then you're going to want to divide both sides of the equation by the cosine of 35 degrees to get the c by itself. Alright, so we have C equals 2 divided by the cosine 35 degrees. So let's use our calculator in degree mode. 2 divided by 35 cosine equals. So if I was to round this to two places, that would be 2.44. So it's approximately 2.44. Alright, so there's side A, side C, and angle B.
2 divided by 35 being.
Number 23 asks you to find the area of the triangle. Okay, now there's two different formulas that we went over for the area of a triangle. We said that if we have an angle measure and the two sides that make up the angle measure, then we have a formula for the area that's 1/2 times both sides, I guess you'd say AB, times the sine of the included angle measure. Okay, and so that was one. The other was Heron's formula that we can use if we have all three sides of the triangle. So on this one here, we have two sides and we have the included angle measure. So we want to use this formula here. That's 1/2 times 1 times 6 times the sine of 125 degrees. 1/2 times 1 times 6, that's 3. So 3 times the sine of 125 degrees. So in your calculator, say 3 times 125 sine equals. Alright, if we rounded that to two places, that would be 2.46. So the area is approximately 2.46. On number 24, we're not given a triangle, so you might just want to draw one. We're given that angle A equals 20 degrees, side B equals 10, and side C equals 5. Alright, so I'm going to go ahead, I'm going to label all the sides and the angles of the triangle, and then I can come back in and put in what they're equal to, what I have. So I'm going to call this angle A, this angle B, and this angle C. So if I label my angles that way, that means that the side across from angle A, that's side A, so that's lowercase a. The side across from angle B, that's side B, and the side across from angle C, that's side C. Alright, so I'm given that A equals 20 degrees, B equals 10, side B, and side C equals 5. So I have an angle measure and I have the length of the two sides that make up that angle measure. So I want to use the same formula that I used in the previous problem. Area equals 1/2 times the two sides, so times 5 times 10 times the sine of the included angle measure, which is 20 degrees. 1/2 times 5 times 10, that's 50 divided by 2, or 25. So it's 25 times the sine of 20 degrees. So 25 times 20 sine equals. If I round this to two places, that's 8.55. So the area is about 8.55 square units. Problem number 25, I'm given side A equals 4, side B equals 5, side C equals 7. So I'm given all of the sides of the triangle, none of the angles. So on a triangle like this, where you don't know any of the angles but you know all of the sides, you use Heron's formula. So for Heron's formula, first we need to calculate what is S. Alright, so S is going to equal 1/2 times 4 plus 5 plus 7. Alright, So that's going to be 1/2 times 16, or 8. So Heron's formula is area is equal to S times S minus A times S minus B times S minus C. Alright, so, and then you make sure you take the square root of all that. Alright, so this is the square root of 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. So this is the square root of 8 times 4 times 3 times 1. Or 8 times 4 is 32 times 3 is 96 times 1. So it's the square root of 96. So you can go to your calculator, 96 square root. If I was to round to 2 places, right here, that would be this. This 9 rounds up to a 10, so that makes this a 0, and this goes up to an 8. So it's 9.80 approximately. 9.80 square units.